morning. As promised, it is new release Thursday, this Thursday before spring break at Butler University. And it's test day, which means, as promised, I am bringing you a little walkthrough video to talk about one of the techniques that may very well be on our test today, which will be trend analysis, aka simple regression in Excel. So now you know that Excel can be used for a lot of different statistical calculations and tests. Some of the tests work really, really well. Some of the tests, maybe there are more robust, better tools out there than Excel. You know, for example, that the data analysis tool pack is part of Excel, and it does give us the ability to do things like ANOVA and t-tests, descriptive statistics, and some rankings. But depending on the tool you're using, maybe an SPSS or SAS or R or Python might be better tools for you. But if Excel's all you got, then sure, these will work just fine. Now, what I want to talk to you about today, though, is actually how you can perform simple regression in Excel using a couple different techniques that do not involve the analysis tool pack. So I'm going to show you how to use the built-in charting feature in Excel. That's one method. And I also want to show you how to do the exact same thing using just functions in Excel. So let's just sort of jump right in. So to give you a little background into the data that we have a really, really small data set of homes. Now, these homes vary in size from 2,000 to almost 3,000, so 2,000 to 2,900 square feet, and we've got the values that go along with those, okay? 2,000 to almost 3,000, and the values as you see fit. Now, that being said, if you were to look at this sample set, well, that's not a lot. So in the statistical world, this would be a pretty small sample of data. So let's just say for the purposes of today, this is your entire block. So this is the population, which means you're not going to really worry about sample size that much because, well, that's every single house there is. So that's the entire population. So that's good. Okay. So what we're going to do first, before we move into just doing simple regression, is we kind of have to check our data to make sure that it is actually linear, and which is one of the assumptions of simple regression. The data actually has to be linear. So now an easy way to do that in Excel is to graph it. You want to get to know your data, and one way to do that is to visualize it in a scatter plot. So what I'm going to do is I'm just going to jump into the Insert tab, which was already clicked. I'm going to go to Charts, and I'm going to use a scatter plot, okay? Now, I don't want Excel to build this scatter plot for me. I'm actually going to do it myself. So I just created a blank scatter plot. Now, from there, I'm going to right-click. I'm going to go to Select Data, and I'm going to click Add, okay? So notice that it already put some data down here, so it's trying to do something for me. I actually need to get rid of that, or it's going to cause an error. So I just want to make sure that's all deleted out of there. And for my Y values, okay, I'm going to add the cost of my home, okay? And now on the vertical axis, you see those pulling in. For the horizontal axis, the X value, I'm going to add my square footage, like so. I click OK, and I click OK again. And there we have it. We've got something going, right? And our data is actually looking to be pretty linear, and that's good. I'm going to go ahead and put a title on here too, just for good measure, okay? So now while I'm in here, I'll close this out and I'll do this again. The next thing I'm going to do, since I look at my data, I go, yeah, it's linear. I think we could maybe do some inferential statistics off this. I think we might be able to make some kind of prediction or a forecast from this. What I'm going to do is I'm going to click this little plus sign here, and I'm going to add a trend line based on our data, but I'm not going to just click it right here. I'm actually going to click this little arrow here, and I'm going to go to More Options, and I am going to choose linear. And notice there are more than just linear relationships that you can use to forecast. We'll talk about these in other videos, maybe this morning if we have time. For now, we're just going to choose linear. We're going to jump down to the bottom. We're going to choose display equation on chart and display R square, and we're going to go and close that out. And what you see now is Excel has told you the formula for linear regression, for simple regression, based on the data that we have, right? And if you remember, that formula is y equals mx plus b, right? Y equals mx plus b. Now, in that particular formula for simple regression, the variable would be 99.64. Okay, so if I'm looking to add a 600 square foot add-on to my house, well, if you took 600 and multiplied it by 99.64, that's going to tell you the value of that add-on. So your house will go up in value, whatever that value would be. Okay, that 99.64 is actually called the slope of the line. Okay. Now, all the different values that you see here, the r square, which we'll talk about in a minute, the slope, and this value, that 48,053, which is called the intercept, are all things that you can calculate in Excel using functions. And I'm going to show you what those are as we talk about what each one is. Okay. So we first talked about slope. We already understand what that is. Think of that like a variable cost. So for every square foot, for every foot that you add to your house goes up in value $99.64. Basically, that's the value per square foot. Now, Excel told us this because, well, we turned on the trend line and we showed the equation. But if you didn't want to chart it, if you wanted to do this quick, you could actually use the slope function. Okay? Slope function is really, really easy. All you have to do is tell it your y values, tell it your x values, and boom, 99.64. Okay, it's that simple. That's how Excel did it. Okay, so now the intercept. What is the intercept? Well, the intercept here is going to be 48,053. Think of that 48,053 like a fixed cost. It'd be a good way to look at it. So say you wanted to build a home in a neighborhood that didn't have any existing homes, just as an example. Before you even built the house, you would still have a fee for the land. Think of that 48,053 like that fixed cost to buy the land. It's not going to change. It's just always going to be there no matter what size your house is. So you're going to start with a base of 48,053 and it's going to go up from there $99.64 per foot. So the intercept here is 48,053. Think of it like a fixed cost. Now we have an intercept function. So I'm going to go known y's. I'm going to go known x's. And boom, 48,052. So we're cooking here. Things are looking pretty good. Okay. So now what? Where do we go from there? Well, first let's go down here. And before I talk about R squared and standard error, let's just go ahead and do our forecast for a second. So with simple regression, if you plug in the value that you're looking to forecast into that linear function, which is part of the general linear model, it will give you a value based on your pre-existing values that you can use as a guideline. So for example, if I took 99.64, okay, which is your slope, times the 3,500 square foot house that I was looking to build, plus the $48,000 that is a fixed cost that doesn't change. Notice that I didn't put parentheses in here. I don't really need to because of order of operations. I click enter and it tells me 396,792.12. That would be a fair market value price for a home in this neighborhood that is 3,500 square feet. Okay. So that's the first thing I wanted to talk to you about. So now the second thing I wanted to talk to you about would be the R square and the standard error. R square and the standard error. So now what is the R square? So I had to turn that on and over here it says 92.33. Think of that sort of like a level of accuracy as a percentage. So think 92%, okay? 92%. So now the R square value is anything, can go all the way up to 1. So from 0 to 1 would be an R square value that you would get. And basically the closer to 1 you get, the closer to 100% linear value or 100% of these dots in what's called a least squares line. So you see this line, this regression, or this trend line is actually called a least squares line. And what it tries to do is it tries to draw a line that minimizes the distance in between each one of these data points. Well, if all of these data points perfectly set on this line, then the R square would be 1, which would be basically 100% of your observations are perfectly linear and they line up just like so. You'll see that there is some variation, right? So the distance between each observation is not perfect. Okay, so you see that? They're not a perfect line. So that gap in variation would basically be the difference between this and 100%. So 8% variation is not being explained in this model is a good way to look at it. So if you're just looking at it for general usage and you don't want to go too deep into it, think that this is 92% accurate, which is pretty good. Realistically, probably wouldn't see that in the real world, but for educational purposes, works out really well. So we'll say 92%. And you saw that Excel did this for you with the chart, but I can do this myself using the RSQ, the R square RSQ function, okay? And the R square function is RSQ. So I give it the Y's, I give it the X's, and I get 92% or 0.92, okay? So now, remember I said just a minute ago, there is some variation. This is not 100% accurate. There is some random chance going on in here. So basically, there's a plus or minus factor here because we don't have a 100% match here. So there's still some variation that you could have in price. You could sell it for maybe a little bit more than what you are asking for. You could sell it for maybe a little bit less within reason. And that plus or minus value is called the standard error. Now, when you do this chart, it didn't tell you what the standard error was, but you can calculate the standard error by using the standard error function, which is STEYX in Excel, STEYX in Excel. So much like the other functions, if I give it the Y's, oops, yep, there we go, and I give it the X's, it tells me 18,144. So that's the variation that we can't quite necessarily account for. So what that means for us is you could sell the house for 396,792.12 plus or minus 18,144.67. Okay. So what will I do here? Well, let's just calculate that. So we'll take 396.72 plus 18,144.67. And we can do the exact same thing. 396,792 minus 18,144.67. And there you go. So my range of acceptable values to sell my house based on these particular values would be between 378,647 and 414,936. Anything in there would be a fair selling price at a 3,500 square foot house. Okay, so the one last thing I want to show you is Excel has some other predictive tools that allow you to do something similar, and they'll give you values that are very, very close to what we just did manually. And these are called forecast functions, and there's quite a few of them, okay? Forecast functions. Now, remember I said earlier that there are different kinds of relationships. Not every relationship is linear. In this particular case, though, we are working with linear data, so we're going to choose the forecast linear function. So what that forecast linear function will do for you, and I'm going to just type right over here. So say, for example, the question asks, hey, well, what if we had a 3,000 square foot house? Is 45,000 a fair market value for that house? Well, we don't know, but we can test for that. And there's several different ways we could do it. We could do the entire process that we just went through, right? So I could jump up here, I could change that 3,500 to 3,000, plug it into the simple linear regression formula, and it would tell me that answer, and that's absolutely acceptable. But if you'd like, you could use a function in Excel that will tell us the exact same thing very, very quickly. So we don't have to go back and do all that math again. And that function for this type of data is called the forecast linear function. So the forecast linear function basically does the same thing that we just did in Excel, just really quickly. So it's pre-built into Excel, so I don't have to use that formula. All I have to do is tell it, well, hey, I want to forecast 3,000, a 3,000 square foot house based on the existing values. So here are my known Y's. Here are my known X's. And I close that off. And it tells me, well, your acceptable price for a 3,000 square foot house would be $346,972.24. Now remember, you still have a standard error, right? And the standard error here wouldn't change. It would still be 18,144. So you'd have to go plus or minus. But you can use the forecast linear function in exchange for using the actual simple regression formula. Okay. Now there are other forecast functions that we can deal with. There's forecast seasonality, forecast ETS, which is exponential triple smoothing, and we'll talk about those in other videos. But for now, hopefully you have a good morning. We'll see you in class really soon. If you're watching this video before our big test today, and for those of you that are just watching because it's the YouTube channel and you want to learn more things with Excel, thanks for joining us. Talk to you soon. Have a good day.